Hello and welcome to the A-Level Chemistry presentation for Suffolk 1. My name is Chris Astley, and alongside A-Level Chemistry, I also teach some of the chemistry aspects of the BTEC Applied Science.
And my name is Derek Charteris, and I teach the other parts of the chemistry specification and applied science as well.
And just like most A-Level subjects, we will team teach an entire A-Level course, both of us covering different aspects. The chemistry we study here is the OCR syllabus, and it's broken up into 6 modules, as you can see on the screen right now. Module 1 we'll come on to later. It's basically the practical skills which occur throughout the entire 2-year course.
The big advantage of A-Level chemistry is that nothing you do in year 12 in the module 1, 2 and 3 is forgotten while you're doing 4, 5 and 6. You won't need to go back and revise things because everything in the first year you'll be using in the second year of the course again. So you actually build up your knowledge slowly. As we've said already, there are 6 modules to cover. Module 1 is the practical skills, which run throughout the whole 2 years, and you'll be developing those skills throughout the whole course as the course changes topics. Module 2, the foundations of chemistry, are the things we learn right at the beginning because you'll be using them again and again in almost every lesson through the 2 years. Module 3 and 5 then cover the physical and inorganic chemistry aspects. Module 4 and 6 covers organic chemistry and analysis.
This is just an idea of the destinations that some of our previous A-Level chemists have gone on to once they finished their time here at Suffolk 1. So you can just see there's quite a lot of variety of what you can do with an A-Level in chemistry. Some of them are quite obvious. You're going on to degrees in chemistry and medicine, obviously it's a requirement. But you can also see there that there's quite a lot of other professions that people have gone on to, such as physiotherapy, criminology and forensic science. This is the main course book that we use throughout the 2-year course, and just a reminder that it's the OCR syllabus that we are following. Within the book, it's always a similar pattern. It's got a little introduction of the topic area, and then it might have some of the key practical skills that might be covered, and then it's got some differentiated questions towards the end.
Plus it takes you a bit further than the A-Level course goes, and the little purple boxes with pluses in tend to be something of interest, which is a little bit beyond A-Level for the people that are interested in that. Some careers you can study, well, these are the general areas. An awful lot of students want to go into some sort of medicine or healthcare, and of course there's a much wider range than people initially think of. It's not just doctors and nurses, there are many other jobs in the medical area which chemistry equips you for, and you need chemistry for. Energy environment, for those who are interested a bit more maybe in geography and other aspects. We cover a lot of things, or we prepare you for a lot of different courses there. If you're doing physics and chemistry together, then material science, something you might be interested in. It's a massive area of development as we need newer materials, we need better polymers that aren't the danger and don't persist in the environment. And manufacturing industry, of course, is still a big employer in Britain, particularly of chemists and chemical engineers.
So just a little note here about the entry requirements for the course. So to get onto the A-Level chemistry course, you will need a grade 6 in GCSE chemistry, or a double grade 6 in GCSE science, grade 6 in GCSE mathematics, and that's due to the, as we'll come on to maybe later on, the high mathematical content within this subject. A grade 4 in GCSE English language or literature, and an average GCSE score of 5.5.
A-Level chemistry is a fantastic course, as A-Level chemistry is an elegant, complete subject that fits together as a whole at the end of the A-Level. Everything you've learned helps you understand everything else and makes sense. It's a bit like a jigsaw puzzle where at the end of the 2 years, everything fits into place. And it's the elegance and the efficiency of it that appeal to a lot of us. Chemistry isn't about writing long essays or writing a lot down. It's about expressing an awful lot in a very small space. So one of the chemical equations will show an awful lot of information. And people who that appeals to, who want to write briefly to explain a lot, normally like chemistry. Within chemistry, we do a lot of monitoring. So you will know how you're doing as you go along. It will not be a surprise at the end of the year or the end of term when you get a test. You will know how you're doing because we'll feed back on the questions you do. You'll get mark schemes to them. We have clinics we offer at lunch times where you can come for extra help, or we'll ask you to come for extra help at times. And there's also lots of enrichment activities going on, such as the spectroscopy workshop at UEA we often attend. A lot of students enter the Royal Society of Chemistry Olympiad each year. And more recently, we've taken part in...
And also, yeah, we've taken part in the Cambridge Lower Six Challenge, or the Chemistry Challenge. This is one of the main teaching labs of A-level chemistry. This is upstairs in P206. And as you can see, it's a very well-equipped laboratory with 2 fume cupboards at the back, and lends itself very well to whole class practical activities. All students are provided with the essential safety apparatus. There's some goggles and lab coats provided when needed for experiments.
It's another view of the same lab, just looking at the 2 sides of it. And there's the other main lab we use for chemistry, which is P207, which is a very big lab with 4 fume cupboards and could take up to 2 classes at once. But for big practicals where we need the space and we need to spread out, we would normally swap into this lab.
This shows you the 12 mandatory PAG practicals that will be carried out over the 2 years. And it's shaped in the form of this pyramid to sort of show you that the practicals carried out in the first year are a little more structured, maybe with a little more details given. And then as the students progress throughout the course, the practicals require you to be a bit more autonomous and to work by yourselves a little more. And eventually in PAGs 10 and 11 becoming very much unscaffolded. And PAG 12 is a research task where you're asked to investigate a particular topic and try and plan and carry out your own activity to find an answer.
Thank you.
Thank you very much.